For the makers who lead, success isn't measured in promises. It's measured in results. At Rockwell Automation, our 24,000 employees across the globe focus every day on delivering business results for our customers. Because with every result achieved, we realize the promise of expanding human possibilities. That's why we're Rockwell. Our customers make products and deliver solutions that touch all of our lives. And they partner with us to realize measurable, consistent, and profitable business outcomes, delivering the real results they and their customers depend on. The people of Rockwell and our vast production technology portfolio make a real difference in industrial production quality, speed, and efficiency, making a difference in ramping up adequate supplies of life-saving vaccines, making a difference by helping deliver vehicles that are affordable, efficient, and safe, making a difference by engineering sustainability into every system and solution we deliver. Because at Rockwell, we believe better is possible. And the results we deliver add value for our customers every day, in every industry we serve. Our systems connect your company end to end with data-fueled insights, improving the decisions that deliver results and expanding human possibilities. Rockwell Automation. Results achieved.
Hi, welcome to our live stream today. My name is Nicole Belanda. I'm a program manager here at Rockwell Automation. And today we're going to be talking about model predictive control technology, specifically for the mining industry, although this can certainly be applied in other industries. And I'll have the opportunity to speak with Lance Rodenfels. He's our Industrial Data Science Global Leader. So before we bring Lance on, though, I want to ask a question of any of you who may have joined through the chat here or who are watching. Is there an area of your operations where you think maybe you could be doing a little bit better, whether it's more throughput, maybe using less energy, using less water or chemicals, depending on what your process is? Is there an area that you just suspect you could be doing better in? And if there is, just drop us a note in the chat and let us know what it is. And we'll get to that, why I'm asking you that, a little bit later in our chat. But let me introduce Lance Rodenfels. So again, Lance is the Industrial Data Science Global Leader at Rockwell. Thank you, Lance, for joining me today.
Thank you.
All right, so we're going to start off kind of base level here. What is model predictive control, which we'll call MPC as we're talking today, and how is it different from standard process control?
Sure, thanks. So model predictive control is exactly what it is. It's we build a model of your process or your assets, and that model allows us to predict what is going to happen in that process or asset that we've modeled. And that prediction is what we use to control the system and doing a closed loop control strategy. So effectively, we're modeling and predicting and then controlling. So the optimization activity comes when we basically are optimizing the control execution based on what is being predicted by those models that's going to happen in your process. And by doing that, we can be more aggressive in the control strategy for those areas and reduce the variability effectively. It's different in the context of most regulatory control strategies that are in play today are going to be a little bit more reactionary to activities in the system. So if you're running a standard P&ID loop, they're going to react to what's going on in the system and then try to bring it back to an agreed upon or a targeted steady state based on whatever gains you have. Whereas with model predictive control, we're predicting what's happening, we're controlling against that prediction, and therefore not reacting, but optimizing the process itself as we go forward.
Okay, that's great. Thank you so much for just starting us off with that baseline. And I mean, it makes sense from what you said. Like if you're predicting as opposed to reacting, you are going to reduce a lot of the time of reaction and have less variability. So cool. All right. So I mentioned before, we are talking about the mining industry today, even though this does apply to many, many industries. What are some typical ways you've seen mining customers of ours use model predictive control?
Yeah. So we've seen our clients use those in a number of different areas. some of the more common areas we see are in terms of the crushing and grinding circuits to try to manage and affect a more consistent output from those areas, either for final product or for further processing in downstream. We've seen it applied in flotation successfully in terms of improving the yield or the production out of the materials. And we've also seen it deployed it in thickening in terms of improving the thickening process or the process in terms of managing through the thickening process to improve that activity from an efficiency standpoint. And then also in general around material flow, either from could be underground areas to optimize the bend fill as you bring your materials from below to above ground, or material flow related to movement in shipyards as well. So we've got a lot of different experiences around that. We've also seen it in some areas where there are drying, where there might be drying processes at the end of mining for mineral components. So we've got a lot of experience in those areas, and we've seen this applied successfully in a number of application areas.
Okay, cool. Yeah. So basically from start to finish of the mining process, except you didn't really get too much into the extraction piece, but like all the processing and shipping, it sounds like. Very cool. Okay, this is straying from mining a little bit, but you've worked with model predictive control for a long time. What is one of the neater applications that you've seen a customer of ours put into place with the technology?
Right. So as an engineer, I think it's all neat because I love watching technology do cool stuff and processes, to be blunt. One of the more interesting and I'd say more sophisticated applications I've seen is on a French fry line. I know it's not in mining, but it is something everybody can relate to in terms of most likely eating French fries. You would think it's pretty, straightforward. Hey, let's make potatoes and make French fries. But if you think about it, you're taking something out of the ground like you do in mining, and you're trying to peel it, blanch it, fry it, maybe season it, and then freeze it and then package it, right? And you're trying to take something out of the ground and then make it into a standard or some level of a standard as you go out to your client in the packaging area. Not unlike what you do in mining in terms of extract and get the materials you need and bring it into some consistency and then, off to your end user or your client. So that was one of the more interesting ones. It's not only the control of the individual assets along those lines that I mentioned, so the blanching, the frying, the peeling, all those things, but also the line control. So we optimize the overall line and we manage the flow of the process as they're cutting and making the potatoes. And we manage that flow into the packaging area to ensure that we're delivering a consistent flow into packaging. And if there is an issue in packaging, we don't overflow and overproduce because it is one contiguous line operation. And so it's very interesting in terms of the interdependencies, the complexities, and how that all works together to produce a French fry and improve the throughput and capacity and yield of those potatoes that come out of the ground.
Very cool. French fries are fun, but that does definitely make me think of mining is also very much in a lot of ways it's continuous where you want to monitor your material flow into your processing into the next step of processing. So definitely able to draw some parallels between that example and between mining, which is where we happen to be focused today. If you are just jumping into our live stream, I'm Nicole. I'm talking to Lance, who is our data science global leader, our industrial data science global leader. We're talking about model predictive control. And if you'd like to, drop us a note in the comments and let us know if there's an area of your process or of your operations that you just have a sneaking suspicion could be optimized a little bit, whether that's more throughput, less variability, better quality, less use of energy or water. I know you have a thought about that. Drop it in the comments below and let us know. And Lance, we're going to move on to my next little set of questions here, which is zooming in on how customers can be successful with this, because I think this is not a super new technology necessarily, but the way that it is applied is what's really important. And I think what we love most about how Rockwell delivers it is our application method. So can you tell us a little bit about, how do customers determine, first of all, where to use this, what to measure and optimize, and how do we help them with that?
Yeah. No, it's a really good question. A lot of clients, as they begin to get into this and the use of, I'll say modeling technology, they will have a focus area or a specific item of challenges or bottlenecks or problems they're trying to solve in specific areas. And they tend to focus on that area, whether it's, getting a better yield out of the material, or whether it's having a more consistent size of the material when it moves out of the grinding and crushing areas. And that tends to be a focus. But what we do to kind of engage with our clients, and that we've been, successful with, and that drives success, is to engage with them through a study or an engagement where we not only understand what the use cases or the concern they have is, but we look at where those types of things are impacted, or how those might be impacted, either upstream or downstream, maybe from where the initial focus area is. So our studies are really intended to make sure we can quantify the value proposition in terms of how much we can impact, whether it's improved throughput, whether it's reduction in variability, whether it's improved yield, but also then begin to align not only between ourselves as a solution provider and the partner, but also with the client, but also internally to the client in terms of what is the problem that's being solved and how will this be solved, and then who will own this solution moving forward to ensure success long term. And so this process that we go through in the study is as much of a technical analysis, an engineering analysis, and alignment of what we're going to do from a scope standpoint, but also the alignment on the business value that it's expecting to drive, and then tying that together in effectively a business case that the client can use to justify the spend in the project moving forward as they go and secure capital, or get the ability, or secure the ability to release that capital for spend. So the study engagement is really critical, because that is the starting point to get full alignment, and then moving forward into a project execution, and then at the end of the day, sustainable engagements related to that solution that was delivered.
Yeah, when I first heard about this study, which I will, this is a paid study, everybody. We can't give all the goods away for free. But what an amazing, I was wishing that there was something like this for any time that I've ever had to present to a leader, like, I would like to invest in this. Here's why I think it would be good. instead of just the gut reaction of, well, I know I want to reduce whatever problem we have. It's numbers, right? It's, if you apply it this way, you can expect XYZ to be your range of results, and your investment would cost this. And so it is truly a full business case that can be used internally to sell the value of the solution before it's even purchased, which is so cool.
Yeah. And if I could just add on to that real quick, one thing that you hit on there, I think is really important. The study is, it is an investment in a paid engagement, but it also, if you think about it, it's a way to help also minimize risk for overall, because again, make sure you're aligning with what the value proposition is. Make sure the solution that's going to be delivered is going to target and deliver on that value proposition. Make sure you have alignment in your organization as well as with the vendor, us, in terms of what is being delivered and what the targets are. How many times do we think we know what the problem is? We have a pretty good idea what that is. We go and, put something in place to solve that problem, whether it's, in business or in your home life, and then you realize, well, that wasn't the problem. I now have to go back to, the Home Depot or wherever and, buy something that, I got to go get again, right? So this is really intended to make sure everybody's aligned, and it mitigates the risk to the larger spend to help solve the problem. So just want to articulate that as well.
Yeah, thank you for adding that in. That's really good. And if you guys listening in are curious, if you'd like to know more about like what's included in one of those studies, how we conduct them, we recently had a coworker of Lance's. Her name's Karen Sacco. She's based in Australia. So we do have global folks on model predictive control. Karen's amazing. Like her second day back from maternity leave, she recorded this webinar for us that goes through a study, start to finish, and talks about, what you're going to see, how it can help you with your decision making if you're looking to implement MPC technology. So that we ran that through Mining Magazine. They invited us to run a webinar with them. You can find it on their website. We'll also throw the link down in the comments once we're all done here today. If you're curious and want to know exactly what it looks like, we can show you that. So again, if you're just jumping in, I'm Nicole. I'm a program manager here at Rockwell. This is Lance. He is our industrial, what is your whole title, Lance?
Industrial Data Science, Global Industrial Data Science Commercial Lead.
Okay, I'm changing your title right now to Industrial Global Data Science Mythbuster, because it is time for our final round, which is some myth busting. And I'd like you to just answer a couple common objections that you hear when you're talking to customers about model predictive control technology. And let us know, are they legitimate concerns? Are they things that you've seen people work around better? Mm-hmm. Kind of give us a feel for a couple common objections and where their validity is.
Right. So I think the initial feedback, or at least my response, is people have seen a lot of promotional information out there around machine learning, data science, AI, all these model-based solutions, if you will, and they tend to kind of become a little confusing, or they tend to be simplified. So there isn't an easy button or a drop ship solution in the context of MPC. It is important to make sure that you have the right case study, or rather the business value, aligned with your use case, and the application of the technology is applied across those areas. So that's where we see, one of the main areas of misnomer or oversimplification, if you will, but it is an important process to go through in terms of that alignment. I guess another misnomer of MPC is that it is a very complicated and maybe an expensive activity and endeavor. And the key is to scale the solution that is being delivered to align with the value proposition and the use cases that you're trying to target. And that's, again, why we go through the study, to align with that value proposition. I think also with, MPC in general, or the context around MPC, is that it's going to replace, an operator, right? That's always another, well, we've got operators, they've known this for years. This is not intended to replace your operators. What it does is, because we build a model of your process, it absolutely effectively becomes and takes your best operator and how they operate your system and applies that consistently 24/7, 7 days a week, as long as you're running the models. And it allows your operators to, do other things that you need your thinking operators to do, and allows the computer and the computer system and the models to take over and run the system, very much like a autopilot or your cruise control in your automobile. It's the same concept. You still need to have someone driving and making, people decisions around, what you want to do, where you want to go behind the wheel, but it doesn't replace them. It allows them to go and make those decisions and do other things, while the main, how fast is the car going, or in this case, how efficient are you driving, how efficient you're running your plant, how fast, those types of things are managed by the computer. And at any point you can take back over. So that is one of the, main, I say, items I think that is a misnomer out there in terms of MPC and what it does or what it doesn't do. So yeah, I think that probably covers the main buckets.
Those were perfect. That was perfect. Thank you so much for throwing a couple of those at us here at the end of our session. So for all of you who are watching or maybe have jumped in halfway through, thank you for tuning in today. If you want to learn a little bit more about model predictive control technology, which I mean, for all of us who are looking to do more with what we currently have right now, it can be a really cool, easy thing to investigate. We have a webinar that is out on the Mining Magazine website. We'll put the link down below in the chat for you, where you can go learn about this study that we perform before we roll out model predictive control to help you understand the best application for your company. And again, we've talked in the context of mining today, but this is 100% a solution that is applied across all the industries that Rockwell serves. I just like mining. That's what we're focused on. But if you'd like to learn any more about this, just drop us a note down below in the comments and we'll be happy to circle back with you and get you whatever info you need. So thank you for tuning in today. Lance, thank you so much for your time. I appreciate all of your expertise today.
Thank you, Nicole. Everybody have a good day.
Have a great rest of your day, everyone.
Bye.